Hello lovers of natural history, Bob Ellis here with you again today with another Notes from the Field. And oh, what a joyous occasion in the Mogollon Highlands. It has been so dry here for so long, and recently we've had a pulse of Pacific moisture bless the land. And so today, what's on my mind is water. And what I'd like to do today is talk to you all about the biologically important characteristics of water, because water turns out to be one amazing compound. And I think W.H. Auden said it best when he said, "Thousands have lived without love, but not one has lived without water." So the first biologically important characteristic of water that I want to talk about is this peculiar temperature-density relationship. Now, water, unlike most other liquids, becomes denser as it cools up to a point. And that point is 4 degrees Celsius. Once water reaches 4 degrees Celsius, it starts expanding. So whenever water freezes, moves from the liquid state to a solid state, it is less dense than when it is a liquid above 4 degrees Celsius. Now you might be wondering and thinking, "Yo, Bob, why is that biologically important?" Well, let me riddle you this. What would happen to the oceans if they froze from the bottom up? There would be no life in the oceans. And so that protective surface on lakes and oceans, that solid layer of ice that floats to the surface because it is less dense than water, serves as an insulating layer to all life below. And so there's several of these characteristics that I want to share with you and emphasize as we have this joyous moment of water in the Southwest. And I thought it would be interesting to kind of go downhill with the water and start in the high country. You can see in the background that Petron montane conifer forest, or the ponderosa pine forest. Petron simply means rocky, so it's the Rocky Mountain pine forest. And we're just going to go downstream through these biotic communities and end up in the desert, where we think there's going to be a pulse of moisture in the desert, and that too will be exciting. Hey, as James pans into this shot, look at the moisture falling in the mountains where we just were. We've dropped 1,000 feet to find ourselves here in the chaparral. This is a biotic community that is also known as the sclerophyllous shrub community. I dare you to try to say sclerophyllous 10 times. And the first part of that word is the word sclera, or the root sclera. And sclera just simply means hard covering. And the reason that all of these plants out here have that hard covering is to conserve moisture. And so as we go downslope and bump into new biotic communities, each biotic community is going to become more and more water conservation focused. In other words, evolution would have selected for different characteristics to hang on to and get more of water. Water is a molecule born out of the weirdest marriage. It is a compound made up of two flammable gases, oxygen and hydrogen. How is it that two gases combine together to form a compound that is a liquid? That's very interesting. Another interesting characteristic of water that is so important, biologically important to life, is the fact that at normal Earth temperatures, water can exist in its 3 states. It can be a solid, it can be a liquid, and it can be a gas. And the implications of that ability for water to change states has tremendous implications for life that we're going to check into as we go downslope. Next stop, Semidesert Grasslands. Look at us now. We've dropped 1,500 feet since our last stop there in the chaparral, and we're in the Semidesert Grasslands. And you can see that the vegetation has changed dramatically, and this is all tied to the availability of water. The Semidesert Grasslands, in the past, pre-cattle grazing, pre-settlement, would look much, much different than what this landscape looks like now. You can see the occasional grasses, clumps of grasses, bunch grasses, which is very characteristic of the Semidesert grassland. And you'll see some shrubs, and most of those shrubs are mesquite, and there are also some prickly pears. So those mesquite and those prickly pears would have been less dominant than they are now before cattle were here. And this landscape obviously is quite dry. For every 1,000 feet that you go up or down, the temperature changes 3.5 degrees. That's the dry adiabatic lapse rate. Now, when there's moisture in the air, that changes everything. And we'll talk about specific heat of water in just a moment. But right now, I would like to focus on the fact that there are plants out here. And you may be scratching your head because it is completely mysterious how plants could survive in such a dry, hot area. And once again, this is because one of the characteristics of water, and due to the fact that water has a certain type of bonding, and it is polar covalent bonding. We'll talk about that a little bit more later on. The water molecules stick together. They cohese. So this characteristic of cohesion, a high cohesion property, allows water, whatever little water there is in the ground, plants are able to, through capillary action, pull that water up in even the most extremely arid conditions. This characteristic of molecules sticking together enhances the ability of plants to pull water up through their roots and then out through their stoma. So you'll also notice that there's no snow here, and it's raining, which bodes well for heading down into the desert. Well, we've arrived in the Sonora Desert. We're probably at about 2,000 feet in elevation, so overall we've dropped roughly 4,000 feet in elevation, which is a pretty big drop temperature-wise. And you'll notice that no longer is there any snow anywhere on the ground, and it's not raining like it was a little bit higher up when we were in the Semidesert Grasslands, but it is sprinkling. And that sprinkling brings a smell to the desert that is exquisite. And for those of you who have never experienced rain in the Sonoran Desert, it is perhaps one of the most exquisite experiences you can have because of the smell. And the smell is the smell that is produced by this plant. This is creosote bush, and creosote bush might very well be the master of the drylands because it has the whole combo platter of characteristics that allow it to be successful in an extremely arid, hot climate. And one of these characteristics is to prevent herbivory, and that means other organisms eating its leaves. And it does that by producing a whole raft of toxic compounds, or compounds that other organisms don't like to eat. And some of those compounds, when the plant gets wet with rain, dissolve off the plant, fall to the ground, and become aromatic. And the smell is just wonderful. And so water is a solvent. As a matter of fact, you will hear water called the universal solvent, and it won't dissolve everything, but that's one of the characteristics of it that is really important to life and can shape biotic communities. There's something out here that I want to show you. Come along, we'll go for a little walk. Like I was saying, water has been called the universal solvent. And that means that it readily dissolves a lot of compounds. And here in the Sonora Desert and many desert landscapes, you'll run into a soil structure called hardpan. And here we have an example of it. And this is a concentration of calcium carbonate, calcium sulfate that has been dissolved from the uplands, water, precipitation falling in the uplands, going underground, dissolving calcium carbonate and calcium sulfate and other minerals, and carrying that mineral downhill until the water evaporates, leaving behind the solute, that thing that was dissolved, and deposit it in a hard layer. And it's one of those self-reinforcing situations, because now the next time it rains, water's going to run downslope, be stopped by the early stages of this hardpan, and add more solute or the dissolved substance until it packs one on top of the other, until you have a very thick layer, hence the name hardpan, and that shapes the distribution of plants that grow on the soil. So there are some plants who have roots, or that have roots that can penetrate that hardpan, and some plants cannot. And so once again, this physical characteristic of water shaping the landscape. Emotional state check-in for Bob? Ecstasy. I mean, what could be better? We're in the desert and it's raining, and we have water. And two characteristics of water: one that is pretty frequently thought of. The other, I bet you don't think of this one. The first one, the one that most people recognize, is transparency of water. Water's a transparent liquid. There are tremendous biological implications for the transparency of water. As a matter of fact, this water in the Santa Maria River is pretty transparent. What are the repercussions of transparency for water? Glad you asked. We remember the three factors that are involved in biological productivity. That is moisture availability, temperature, and nutrient availability. Well, water, freshwater and saltwater systems that lie within the photic zone, that means that zone to which sunlight can penetrate and photosynthesis can take place, are some of the most productive biotic communities on the planet. Any littoral zone, that simply means a shoreline. Coral reefs, perhaps one of the most productive biotic communities on the planet, lie in that photic zone. And saltwater marshes, freshwater marshes, all extremely productive, and mainly because water is transparent. Plants can photosynthesize in the water. Now, the one you haven't thought about, that is compressibility. Water is a liquid that is virtually uncompressible. Take the deepest point in any of our oceans. The degree to which water is compressed, literally miles below the surface, is only 1.8%. So water maintains its density throughout the column. And that's incredibly important for life, because if it didn't, if it were more compressible, life would be forbidden at some point due to the structure or the density of that water. Okay, you're probably thinking, oh my word, Bob, there's no way possible that, woodpecker, that there are any more characteristics of water that are biologically important. And that's where you are wrong, because there are two words that I want to give to you, and they are stability and moderation. Water has one of the highest specific heat measures of all substances on the planet. What is specific heat? That simply is the amount of energy required to raise the temperature of a substance 1 degree Celsius. And this characteristic of water provides for a stable environment for creatures that live in it. And the other thing it does is provide a moderated climate around bodies of water. So we're all familiar with places where if they're oceanside, the temperature swings, the diurnal and nighttime temperature swings are really small because that body of water is moderating the temperature. So water can absorb a tremendous amount of heat and then release that heat just as slowly, which is very important for life. And whenever you think about it, we're 65 to 75% water ourselves, as is all other life. And that means that that water helps moderate our temperatures as well. So just when you think we might be finished with biologically important characteristics of water, Bob drags up another one. And this one is related to specific heat. And this is called latent heat. And that is the amount of heat required to change from one state to another. For example, from a liquid to a solid, water to ice. And this is a weird characteristic. For example, if you were to change the temperature of water from 2 degrees Celsius to 1 degree Celsius, that would take a certain amount of energy. But if you want to go from 1 degree Celsius to 0, a change of states, it takes 80 times the energy to move from 1 to 0 than it does from 3 to 2 or 2 to 1. So this latent heat obviously adds a moderating effect, but it also signals something else, that energy is released at times. Whenever we have a change of state from a gas to a liquid, tremendous amounts of energy are released. And you might be wondering, what the heck does that have to do with biology? You know what, I'm glad you asked, because we experience a monsoon season in the Mogollon Highlands. And a monsoon season is dominated by thunderstorms. What's happening during our monsoon season? Moisture is sucked up from the Pacific coast and the Gulf of California and pushed aloft, cooled, and that pushing aloft comes from heat in the land that has been gathered throughout the hot month of June. That moisture is pushed up, cooled off, condenses, and then falls as rain. But in that change of state from a gas to a liquid, untold megatons of power are released. And that power kind of self-perpetuates the thunderstorm. It grows larger, sucks up more moisture, hits the atmosphere and cools off the top, and we have one of those enormous anvil tops, those cumulonimbus clouds, lashing the earth with tons of water. In many cases, that water is forced to run off into drainages like the Santa Maria River behind me, and that flush of torrent, that flush of water changes the biotic community, or I should say, shapes it. So that characteristic, latent heat of water, can change landscapes. Just like, well, you know what I mean. Hey y'all, I'm so happy that you all came along with us today on this trip down from the Ponderosa Pine Forest to the desert, thinking about those biologically important characteristics of water, and landing here in the desert where when it's raining. Man, how special is that? And I'm really, really happy that people are watching these videos. We have quite a few subscribers now, and gosh, I love that. If you haven't subscribed, boy, you could make my day even better if you go down there and hit that subscribe button. And give us a thumbs up if you like what we're doing. You can also find yourself over there to our website, naturalhistoryinstitute.org. And why don't you look in there and see what you can find that you might be interested in. I think you will find some things there. And finally, I want to thank James Holder with his steady hands and keen eye. It's been a great pleasure, and we look forward to seeing you next week. And so I just wanted to leave you with a quote, one of my favorite quotes by Loren Eiseley. He said, "If there's magic on this planet, it's contained in water."